Hello everyone, welcome to my class. As you all know about mathematics, mathematics is a branch of science, and one very important chapter that comes in mathematics is probability. In the same way, statistics also have one chapter that is called probability. It means one chapter that connects both mathematics and statistics together is probability. Why do we study probability? Is because in statistics we wanted to predict about the population, and whenever the thing come in our mind about predictions, we always have to refer to the chapter called probability. So in our today's class we will learn about a very important field of statistics that is called probability. We cannot learn probability in statistics if we don't know about a term called probability distribution. And we cannot learn about a probability distribution if we don't know the term called random variable. So in our today's class we will learn about what is a random variable and how many type of random variable are. And we will also learn about probability distribution later, because we cannot learn about a probability distribution if we don't know about a random variable. So let's start learning what is a random variable. Let's take example of a guy who is Andrew. Andrew flips a coin. And when Andrew flips a coin, he knows that only two things can come. Either a head will come or a tail will come. And this is known as an outcome. Andrew know in his mind that if he toss a coin, he wanted to know something. Because in probability, we wanted to know something. We wanted to know the chances of something. And here Andrew wanted to know the chances of head. Andrew know in his mind that head can come 0.5 times and tail has chances of coming 0.5 times. It is very easy probability, right? But if Andrew want to make a probability distribution chart or a probability distribution, Andrew cannot use his intuition. He has to take the help of something. And the thing of which he will take help is called a random variable. So what did we learn? We learned that you cannot make a probability distribution. Andrew cannot make a probability distribution if Andrew do not take a help of a variable called random variable. Now just think, if Andrew uses intuition, Andrew can make this table. The probability of getting head is 0.5, probability of getting a tail is 0.5. But as I told you, if Andrew wants to make a probability distribution, then he cannot make this. He has to make this table in a different way, and this is how his table will look like. What we see is that Andrew has taken a help of a variable called random variable. Andrew knows that if he toss a coin only once, then either head will come or head will not come. It means tail will come. So there is one possible outcome in which head will not come, and that is tail. So the outcome in which only tail will come, Andrew will give that a name 0. 0 because Andrew will not see in head in that outcome. Now only one outcome will be there in which head will come. It is head. And head will come only one time. It means Andrew will give another outcome the name 1 in which head will come. So random variable 0 stands for when he will not see head, and random variable 1 stands when he will see head. So random variable x can be two outcomes. It means head has two outcomes possible, in one in which head will not come and one in which head will come. 0 head will not come, 1 head will come. So first variable will be 0 and second variable will be 1. As we can see, our second variable, second term is number of outcomes. When head will not come, it can only happen one time. When you will see head, it can also happen one time. So number of outcome is 1 and 1. It means we have total two outcomes. Head will come or tail will come. So number of outcome in which head will not come is only 1. So probability of getting not getting a head is 1 by 2. And probability of getting a head is also 1 by 2. So what we learned here is that we have to make our table like this, and this table is called probability distribution table. It means Andrew cannot draw the table which is above. Andrew has to make table like this which is below. And we know once we have a table, we can make a graph. And this is how our graph looks like. On the y-axis, we have probability. On the x-axis, we have number of heads. Because we wanted to know about our event is knowing number of heads. The random variable x can be 0 and 1. 0 means how many chances are there that you will not see a head. It is 0.5. And how many chances are there you will see head? It is 1. It is 0.5. So this is a probability distribution table, and this is a probability distribution chart on my left. And do you know how Andrew was able to make it? Yes, with the help of a variable called random variable. Although it looks like that why there was a need to do this, because Andrew can make table like above as well. But the point is Andrew cannot make table above like this if the number of trial here Andrew toss the coin only once. If number of trial increase, then Andrew has to go with random variable. Otherwise, for Andrew, finding probability will be very, very difficult. That is why random variables are very helpful. So what is a random variable actually? A random variable value is a random variable value which is given to an outcome to act as a mathematical function for a sample space so that a probability distribution can be made. So in order to do a mathematical calculation, we have to give a mathematical function to to our sample space, and that is why a random variable is used, and that is the meaning of a random variable. So our outcome was head and tail. So we give it a mathematical function. In order to act on that probability, in order to solve it in a mathematical way, we have to give an outcome, a value. And our value of head was 0 and value of tail was 1. As I told you that Andrew was very happy when he tossed the coin only once because he can solve it in his mind as well. But when number of tosses increase, when number of trial increase, Andrew has so much difficulty in finding out the probability, and the only way he has is finding the answer with the help of probability distribution table and use of random variable. So let's see Andrew flip a coin 5 times. He wanted to know how many times head will come when he flip it 5 times. So if Andrew flip a coin 5 times, he has a very big sample space. The sample space is like this. If Andrew throws a coin 5 times, there are 32 ways in which he can see those 5 time tossing of coins. For example, if he tosses the coin 5 times for the first time, he will see head, 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 head. But there is chances that he can also see first time he tosses there will be head, second time he tosses there will be a head, third time he tosses there will be a head, fourth time he tosses there will be a head, in the fifth time he will show a tail. Look at the third situation, he can also see 5 time tossing coin like this as well. So Andrew actually has 32 ways in which he can see 5 time tossing a coin. And these are known as sample space of tossing a coin 5 times. Now it is a very big problem for Andrew because he cannot predict in his mind that zero point 0.5 chances are there of this thing, zero point 0.5 chances are of this thing. Andrew has to take the help of a word called random variable. Let's see how random variable will help Andrew. So let's see this situation. We have 6 possible outcomes. Possible outcome 1 in which everything that will come on the top on a coin will be tail. Second possible outcome, in which only time head you will see is only one. Third possible outcome, that Andrew will see two heads. Fourth possible outcome, Andrew will see three heads. Fifth possible outcome, Andrew will see four heads. And the sixth possible outcome, that Andrew will see all six, five heads. It means there will be no single trial in which he will not see a head. Every time Andrew tosses a coin, it's a trial. So if Andrew see the possible outcome that in which he will see all the tails, he will never see a head. So number of head will be 0. In the second case, number of heads are 1. In the third case, number of heads are 2. In the fourth case, number of heads were 3. In the fifth case, number of heads are 4. In the fifth case, number of heads are 5. So according to our previous example, if Andrew will not see any single head, it is only the first possible outcome, and Andrew will give it a name called 0. In the second case, Andrew will see head only one time. Andrew will give that case a name, random variable 1. 1 stands for only one head. Now in the third case, Andrew will see two heads, so he gives the random variable to this situation as 2. In this way, Andrew will give all these situations a random variable. This will make very easy for Andrew to know the probability. The probability of getting a head is very easy to understand by Andrew if Andrew make use of random variables, and this is the only way he can make a probability distribution, and it is the only way which makes Andrew very easy to understand the chances of getting a head. So let's see the same table we saw previously. Now we have random variable 0, 1, 2, 3, 4, 5 given to all the 5 possibilities. In the first possibility, Andrew will see head. The first possibility can come only 1 out of 32 times. The second possibility can come 5 times out of 32 times. Second possibility can come 10 times out of 32 times. Third possibility can come 10 times out of 32 times. Fourth possibility can come 5 times out of 32 times. And fifth possibility, that you will see all the head, can come only 1 out of 32 times. So we know we have 32 outcomes, and the possibility of first situation and outcomes that can come in that situation is only 1. So probability of getting the first outcome, the first situation is 1 by 32. The probability of getting the second situation is 5 by 32. Is because we have second possibility can be seen in 5 ways. Third possibility can be seen in 10 ways. So the outcome, we have total outcome 32. So the probability will be 10 by 32. In this way we can see all the possibilities, and finally we can make a chart of this or a graph of this particular probability for Andrew, so that Andrew can easily understand that what are the chances of getting ahead. So what are the chances of getting ahead? Andrew can see easily with the help of this table. He can see that the first possibility has only point something like chances like 1 by 32, and the possibility of second possibility has chances, and third possibility has more higher chances. Fourth second and third possibility has very high chances, and fourth possibility then again has low chances, and the fifth possibility has again very rare chances. I think it looks very easy for Andrew, right? It is easy for Andrew to see this, and it is also very easy for Andrew to draw this. And what makes him to draw this? Yes, Andrew take the help of random variables. So we have two type of random variables Andrew can make. If Andrew makes number like 0, 1, 2, 3, Andrew call them discrete random variables. If Andrew make variable like this, like 42.37, 42.1, or 1.36, When Andrew have so many outcomes, Andrew can also use continuous random variables as well. So there are two variables Andrew can use, discrete and continuous. So a discrete random variable is counted always in whole numbers 1, 2, 3, 4, 5, 6, 0, like, and a random variable which is continuous can only be measured in fraction or decimal, and it is only used when there is a range. Now, because now we understand what is random variable, and we also see how Andrew makes a probability distribution, we can understand what is the meaning of probability distribution. Writing the probability, yes, writing the probability of all possible random outcomes. How many random outcomes we were having? Yes, we were having 5 random outcomes. And when we write the probability of all those random outcomes with the help of a random variable x, you can also take y, is called probability distribution. If we make a table out of it, we call that probability distribution table. And if we make a graph out of it, we called it a probability distribution graph. These graphs are very helpful in statistics because they help us in knowing what are the chances that a particular sample is very close to the population or not close to the population. It helps us in predicting. So students, thank you so much. In my next video, you can see two amazing kind of distribution, that is probability distribution um, of two type. One is binomial distribution and one is Poisson distribution, which are very helpful in predicting about the chances of an event. And now it will be very easy for you to understand our further coming chapters, that are binomial distribution and Poisson distribution. So thank you so much for listening to our lecture. See you in the next video.